All right, good evening, ladies and gentlemen. Welcome to what is actually the second stream of the day. If you notice, I actually do have an AirPod in right here. I'm gonna give myself. I'm just talking aloud for a couple seconds because the reason it's the second stream of the day is we had some technical difficulties earlier, and that prevented. Okay, it is working. All right, so I just had my iPhone over here. Okay, so I'll pick this up. Sorry. Okay, so everything appears to be working this time. All right, so just to recap what happened. At 3 o'clock today, I started to do this stream, and I got about 45 minutes in, and then somebody, actually Stephanie Blaine, very nicely stepped in and said, hey, I can't hear. And it turns out that my audio was totally disabled. I just got this brand new microphone because I was using my headphones, as you might recall. So this is like a Blue Yeti microphone. It's nothing super fancy, but it's nice for them, like your run-of-the-mill iPhone microphone or whatever. But apparently I didn't have it hooked up right, or some software thing was messed up. So yeah, I basically got 45 minutes into that stream, zero audio, and yeah, not great. I'm gonna hold on just a second. I'm gonna text my wife. Can you check the stream quality? Sorry, I just texted her over iMessage on my iMac, or on my Mac Mini here. I just want to make sure that everything's fine this time because, like, so as you might have noticed, we have a new countdown stream thing. Yeah, unable. Come on, seriously. Okay. Okay. Sorry about that. So we have some new graphics, or not really a new graphic, but like a new countdown stream thing that I just enabled. Come on, Maggie, please. Okay. So sorry, my wife is giving me a headache about because I wasn't too happy earlier, and well, I'll tell you why. So, no, I'm not going to tell you why, or maybe I'll tell you why in a bit. Maggie, the stream is live. Okay, sorry again. So she doesn't want to check the stream because she's mad at me right now. So I don't know what to say about that. But anyway, yeah, so I'm trying out new things. So you can see that my logo is down here in the corner. Actually, you'll see now whenever I do a screen share that like my little window will actually become like a rounded window. So it's just nice. I've been trying out new things. So I'm using some software called OBS Studio, yeah, it's been really nice, and it's been it's not been the easiest thing in the world to set up, but it's free, and I think it's done a really good job so far, pretty much. Okay, so let's go ahead and get into today's topic. So, as you can tell by the stream title, we are jumping into a new project today. Now, for those of you who are interested in the Titanic project that we were working on, don't worry, we will get back to that. I just thought it'd be fun to pivot over to something else, just for the time being, especially as we may use this new model that I'm creating for a future like ML Ops series. So, by the way, well, no, I won't get into MLOps yet, but I want to give a quick background on why I'm doing this project. So, I am an avid podcast listener. I listen to a number of different podcasts. I jump in and out of podcasts here and now and then. Like I'll get into a kick on one and then quit it for a while and then maybe come back to it. There has been one podcast that I've consistently listened to all the time, and that is this podcast called The Water Cooler. And so The Water Cooler is this podcast with 5 coworkers, 5 guys, who after their day of work, they'll get around a table and then talk about just whatever in a lighthearted capacity. So they'll talk about their days, they'll talk about movies they've seen, they'll talk about how their families are doing, they'll talk about food, just anything. It's really lighthearted. I will say it is it is very not safe for work. But so they do have recurring bits in the water cooler, and one of them is a rating segment. So it's usually for movies. So one of the hosts of the show, Kalen Bean, who is also the son of actor Michael Bean, will rate whatever on his scale. So he actually gives 2 ratings to things. So one is a like a binary yes or no, basically, like I approve or disapprove. And so, by the way, if any water cooler folks are out there are actually listening, you'll recognize that I'm purposely not using the actual words they use. And that is because the actual words they use are very unsafe for work, and I'm not even going to use the name of the real segment. But anyway, so he gives 2 scores. So one is a binary yes or no, like I approve or disapprove, and then the other one is a single decimal floating point between 0 and 10. So like more specifically, like so we'll give a 1.1 or an 8.8, and that is lovingly referred to as the Bean scale. So about 9 months ago, I posted in their Facebook group, and the water cooler guys are really interactive with their audience, that I thought it would be funny to like create a predictive model around Kaylin's scoring of things, specifically movies, just because that's what I can do as a machine learning engineer. And they caught onto it, and they thought the idea was cool. So I thought, let's go ahead and do this. I've been working on this lightly for the last 9 months, and you'll understand what I mean by the last 9 months with working lightly. But now that I'm like kind of into the meat of things, I'm ready to start actually creating the predictive model, even though like the preliminary stuff is not quite done. So, all right, let me go ahead and share my screen, and I want to talk through some things. Where's my screen share thing? Okay, so I am actually writing a blog post in association with this stream today, and I know I don't normally do this, but the reason I am doing it is because I'm really fascinated by this, and I like doing the blogging, I like doing the live streaming. I probably won't do this one-to-one matching of a live stream to a blog post moving forward. This is just like a special exception. So this blog post is not yet live. I'm hoping to finish it up later this evening and then hopefully get it published out there. If not tonight, excuse me, I had Chinese tonight and it is just not cooperating with me right now. TMI, sorry. Oh, by the way, I do have the chat open, and I am monitoring it all the time. I will answer questions as they come up. Just note that it seems like there's about a 20-second latency in between, like whenever I actually say something and when you actually hear it. And 20 seconds is a lot longer than you might think it is. Anyway, feel free to ask those questions. So like I said, I'm hoping to get this up later tonight, and we're basically going to be recapping or like covering this whole blog post content as part of this live stream. So to lay like the foundation of where we're going, I created this little flow chart here. So the first thing we're going to be doing is creating or gathering the data that we need. And so I'm not going to talk about that more right now just because that's what this stream is intended for. Next, we're going to, just like with the Titanic feature set, we are going to do some feature engineering on the data that we will collect from the various sources. Next, as you may recall from the Titanic data set, whenever we did our binary classification modeling, we just stuck with a random forest classifier. In this actual modeling segment, I do want to actually try out different algorithms. And so the reason we didn't worry about that with the Titanic data set is because I didn't really want to go super deep into like a topic like this, but because I'm trying to create a predictive model that does its best to predict Kaylin's ratings on future movies, I'm going to take this algorithm section or selection a little more seriously, and so we'll cover that as part of its own blog post and stream. Next, we'll move into actually creating that full model training pipeline, and then finally, we will wrap up the series with creating an inference API. So this actually is, this is the end, will be the end of the series in itself, but like I mentioned toward the top of this stream, I do probably want to use this to support maybe some MLOps future posts. So if you don't know what MLOps is, or maybe you know what DevOps is. So DevOps is this idea that, you're constantly writing your code, pushing it out to a code repository like GitHub, GitLab, and then having a continuous integration, continuous delivery, also known as a CI/CD pipeline, constantly, as the name implies, taking that code and integrating it and pushing it out into production. So MLOps, basically the same sort of idea, except for machine learning. So like, let's say, as you may, I don't think I've ever actually talked about this on streams before, but models aren't, let me rephrase this. Most models have what they call decay over time. And so what I mean by decay is that, models are usually trained on a fixed date in time and therefore represent the data as it was collected at that time. And so the problem with that is, is the data changes over time. So a great example of this is, a lot of people over the years have been collecting gender information simply as male or female. So like, let's say you train a model and then it's accounting for male or female in some capacity. Well, with more, like as we get into our more modern age, we are now starting to recognize non-binary classifications. And so we might call it non-binary. There might be a trans category. And so the problem with a model that only was trained on male-female data is it doesn't know how to deal with this new data that's coming in. And so the way that you account for that is by retraining the model with this new information. And so that's what this whole MLOps thing is about, is it is creating a mechanism that will retrain your model on a periodic basis, and then you can have a human review it before it gets automatically deployed out to production, or you can just deploy that new model out to production as part of this whole MLOps flow. And so the inference API, so specifically these last two pieces, the model training and inference API are pivotal parts to that MLOps flow. But that's a whole series in and of itself that I'm not gonna cover as part of the movie rating model. But anyway, sorry for the little diatribe there about that. Okay, so as I noted, Kalen has two different kinds of scores for his movies. You said, I mentioned the binary disapprove, approve, disapprove, a 0 or 1 basically, and a 0 to 10 float score. So he'll give something, like, a 6.3 or a 7.2, things like that. So naturally, we're going to need to create two predictive models. One is going to be that binary classification, and one's going to be a regression model. So we're going to need, in addition to this data, we're actually going to use so like, for example, whenever we actually build a classification model, we'll use the float score as one of the features, and vice versa, just because, they may, actually, I don't know if I want to do that because they may or may not have unfair correlation. I think I'll go ahead and do it. Okay, but anyway, yeah, so that's what we're going to be building, and so we need a couple of things that we're going to be doing as part of this post with data gathering. So the first thing that we'll need to do is get Kalen's actual scores, which are obviously going to be the Y value here in our predictive models. And then we'll need a bunch of movie features from different movie sources to actually support the model itself. Okay, so to that first point, actually getting Kalen's scores. So you obviously, so the water cooler is not, or what am I trying to say here? I was going to say the water cooler is not super popular, but that sounds mean, and I really love the water cooler. But there was nobody tracking this information before. So in order to get all of Kalen's ratings, this is going to sound crazy, but this is actually what I did, is I went through the full back catalog. And this is the 9 months that I'm talking about here. I've gone through the full back catalog and listened to every water cooler episode just to build this Google spreadsheet right here. And so actually, I'm not even done. I'm about 3/4 of the way through, and but one of the hosts of the show, Matt Fondolira, made mention that he's probably got enough data to get started, and I listened to him say that 2 or 3 weeks ago. I was like, yeah, you know what, Matt, you're right. You are right. So let's go ahead and at least start this thing off, because the logic is not going to change. We can always, with that whole MLOps thing, we can continually retrain the model as Kalen continues to review new things. But yeah, I think we have enough information here. So one thing to note, as I kind of alluded to earlier, Kalen doesn't just rate movies. He rates also TV shows, foods, and other random things. So you can see here, he has rated the United Kingdom a 9 out of 10, and it is a positive yes score. Or he rated tonsil hockey a 0. But that's only because he didn't know what this was, but stuck to the score even after learning its real meaning. So, I mean, there's just a lot of funny stuff in here. And so the reason I kept all this stuff in here is because the water cooler guys appreciated it, and I think it's funny. But for our actual model, we're not going to need most of this. Okay, so like I said, I've been capturing this all in a Google Sheets, particularly on my iPhone. So anytime I listen to another entry in the podcast, then I will like scroll down to the end of the sheet here and then append it on. So you can see I made it through. I've made it through 242 episodes, and this podcast runs a solid hour, if not a little bit longer. So that's a lot of water cooler, and that's almost embarrassing to admit now. But it's a very lighthearted podcast, and a lot of I'm kind of a weird dude in the sense that I listen to a lot of philosophical or philosophy podcasts, and so like it's just heavy, or those podcasts are really heavy, and whereas like the water cooler is like really like the opposite of that. Like it's lighthearted and it doesn't take itself too seriously. Okay, so and one thing to note there, you might note that there are 3 tabs on here. So with the water cooler, there are three kind of shows almost. It's all one show, but so there's the main show, of course, and that's got all of this stuff. Then about this time, about midsummer last year, they started a Patreon podcast. And one thing to note is I haven't been keeping this up to date as things like progress, just because like I don't want to confuse myself on where I got lost at. So I've just been populating them as I get through the back catalog. So you can see I just now started to get back to the Patreon episodes, but there's actually been like 55 or so Patreon episodes so far. And then finally, they recently started this thing called Movie Night, where they will watch a movie and then basically give their own commentary on a movie, and then you can like synchronize your like own copy of the movie, so you can watch it as if you're watching like their director's commentary. So it's pretty funny. Although I will note in here, so kind of funny story. Like I said, the water cooler guys are very engaged with their audience. They recently watched Air Force One as last month's movie night. So last month being August, September, they actually did a movie called Hush. But Kaylin rated that on the main feed, so that's why Hush is not in here. But they never, like, Kaylin thought at the end, so he actually gives his scores at the end of these movie nights, and he thought he gave the score for Air Force One and didn't. And so I brought that up, and he didn't really believe me. And so I've asked 3 times now for this particular Air Force One score, and he still hasn't given it to me, so that's kind of funny though. Anyway, so the first thing that we're going to need to do is translate this Google Sheet into a something that we can work with in a pandas data frame. And so I honestly don't remember how I necessarily did this the first time, or figured this out the first time, I should say. But I figured out that there is a way to directly query data from a Google spreadsheet from like a Python script, which is really nice, because I was afraid that I was going to have to like actually manually save off this Google Sheet as a CSV spreadsheet every single time. But no, that's not the case. Also, funny thing here. So this is my GitHub README here. I did write my own background on that's kind of like a tongue-in-cheek joke for the water cooler guys. So this is going to sound really stupid, but like as like a greeting / sign off, we bark at each other. So I was writing this README, and you can see that I put woof woof at the end here, but I forgot to do that as part of my last Git commit. So you can see my last Git commit was that I added to bark, and so I note that I forgot to bark. It's so stupid, but great. Anyway, so back to Kaylin's spreadsheet, or back to what I was going to show here. So when I come to the notebooks here, and then I check out this load from Google Sheets. So I don't remember, I hope it loads up. Okay, I don't remember how I got my Google Sheet ID, but I Googled somehow that I could use this Google Sheet ID to basically do what am I doing here? I'm just reading this here. Okay. Oh, that's interesting. Yeah, so I was basically able to read this data with this little function here using my Google Sheet ID and then also the sheet names. So you can see that I created this little function here in order to be able to do that. And then down here, I'm actually getting each of the data from each of the sheets here. So you can see I'm getting it from the main feed, I'm getting it from the Patreon feed, and I'm getting it from the movie feed, and then I'm concatenating them all together. So when that's done, and you just look at the first few rows of this data frame, you can see that I get basically the same thing that we're showing here, except in here. Now, of course, we only need the movies, so that is why I created this movie category, so that way we could just do a quick filter down based on movies. So we're going to do a df category equals movies, and that is just going to leave us the movies. And then, of course, there are a couple of things that I could put in here just for like the water cooler guys' sake or just fun, and that is like the episode number and just like general notes. We don't need those for our predictive model, nor do we need the category anymore since they're all movies now. So we're free to drop all these, and so we're going to drop category, we're going to drop episode number, we're going to drop notes, and then all we're left basically is just the movie name, the rating on a scale of 1 to 10, and then the positive yes or no rating, and then we save this out to a pandas CSV. So that's part one. Part one's not too difficult in the sense of like actually getting the data from the Google Sheets into like this Python script. I think some people might think I'm crazy that I went this far back through the back catalog of the water cooler to get all this data, and I'm still doing that. But like I said, I listen to so much like heavy philosophy stuff that this really is just like a breath of fresh air, if you will. Those guys are super nice. I've never actually met them in person, but I would love to. They have mentioned before that they want to do a water cooler meetup in Las Vegas, so I have not put my name in the hat yet because I don't think my wife is going to let me, to be honest. But I would love to be able to join those guys out there for their Vegas meetup whenever they do that, probably in the first quarter of next year. Okay. So the next thing we need to do is actually gathering the data for our project. So as you might recall from the Titanic project, let me stop sharing for a second. So as you might recall from the Titanic project, I need to take a sip. My mouth is getting all like cotton mouth from talking so much. Oh, so that's what I was going to say about why my wife is kind of irritated with me right now is because I had so the water cooler guys like to drink White Claws as kind of an insider joke. So I went, and there's actually, so down in my little, you can't see it, but there's a mini fridge down there. I got like a big tall like White Claw, and I was gonna drink it live on here, but my wife thought that was a really bad idea from a career perspective, and I honestly am up in the air whether or not like that was a good or a bad idea. But she kept, yeah, like I don't know. I got kind of mad at her about it. I guess and then she got mad at me about it. But it's kind of, I don't know. She's definitely right about this. So I am sorry. I'm sorry, honey. Yeah. I don't know. I'm still kind of mad at myself also that I screwed up the earlier stream so bad. But anyway, so where was I going with the White Claw thing? I guess her biggest concern also was that I don't drink at all, and so I'm a huge lightweight, so this stream could have just gone south really quick if I would have pulled that White Claw out of here. Oh yeah, we were talking about the Titanic data set. So that whenever we started working with the Titanic data set, we pulled that data set from Kaggle, and it was basically data handed to us on a silver platter. And unfortunately, that is not going to be the case for most data science projects in the real world. You're either going to have to go out and hunt for your own data, you're going to have to create your own data, you're going to have to dig it through archives to find data, you might have to get data from like 5 or 6 or even 50 or 100 different sources, and you're just going to need, and it can be difficult. It's not going to be Kaggle where they just hand it to you on a silver platter. And Kaggle's great, don't get me wrong. It's great for learning and it's great for data science contests, which is what it's designed for. But whenever it actually comes to creating your own model, it's unfortunately not going to do. So as far as actually getting the data that we need to support our effort, then where do we begin? So I want to put, let me go ahead and share my screen here again. Okay, so this is I started to mention this as some challenges that exist whenever you actually create your own data. So questions that a data scientist might ask themselves include things like, does the data exist? Oh wait, no, I did put the exist. Does the data to support a potential model like this exist? At least I could say even before I started doing my work here with some confidence that movie data exists. Obviously, I know what IMDb is, and so yeah. So what sort of features do I need to gather when creating my model? This is a tough question to answer, because I'm not like a movie buff or anything. And especially when it comes to features, you can't use a feature like, does Brad Pitt star in this movie? Because it's obviously going to be skewed toward most movies don't star Brad Pitt. Like Brad Pitt probably stars in like 0.00001 of movies, 1% of movies. So you have to find features that are relevant to all movies. And so a great example of this might be like runtime. Every movie has a runtime. Every movie has Well, theoretically, every movie has a Rotten Tomato score. Every movie has revenue. Every movie has a budget. And so that's the sort of data that I'm going to be looking for. By what means do I need to curate the data in its raw form? So that's talking about like feature engineering. And then am I going to have to do a lot of feature engineering against the raw data? Oh, do I need to... by what means do I need to curate the data in its raw form? So this is where I'm talking about interacting with APIs and whatnot. And we'll talk about like some challenges that I've run into with this. But continuing on, is the raw data actually representative of the inference underlying the model? So that is just basically saying, like, are you using data fairly, or like is it actually like legit, or is it just like some weird coincidence that you're getting some sort of inference based off of the data that you're putting in? And then finally, does this data create an unfair / ethical bias toward one direction on the influence? So inference. So fortunately, I don't. This model is not. I don't think has any risk for like unethical behavior or whatever. So what I mean by that is the example that I always love to use is, let's say you wanted to create a predictive model for selecting a data scientist, for selecting a CEO today here in 2021 using data from the 20th century. And so the reason that can be very unethical is because if you think about like the CEOs of the 20th century, most of those people were middle-aged white Caucasian males. And so if you build a predictive model using that data, and you wanted to get inferences on who's going to be the best candidate for a CEO just based off of that data alone, the model's always going to give you back a middle-aged Caucasian white male. And I'm not saying actually I'm half Hispanic, but I don't have anything against white males per se, but obviously those systems of oppressions in the 20th century were the reasons why we didn't have like female CEOs or CEOs from different minorities. So it is highly, highly, highly unfair to create a predictive model, and it is highly unethical to create a predictive model to select CEOs based off of 20th century data. So that's what I'm talking about in here. I wrote basically the same thing. So I'm using this post as like a guide to help me keep on track, partially because I'm still a little like brainwashed from the fact that like I had to cut that whole stream earlier, like because the whole audio is gone. And then also just because like, it's starting to get late in the day. And if I try to remember everything I wrote down in here, it's just not going to go well. So, okay, I'm just reading through this real quick to make sure that I didn't miss anything. Oh, so this is a good point right here. So one thing that I do also want to be mindful of is making sure that whenever I collect data from one source about a particular movie, that whenever I go hit up a different source, I am ensuring that I'm getting data for that precise movie. And so the example that I'm using here, is Avengers Endgame. So like, let's say I hit up one source for data for Avengers Endgame, and then I go try to hit up another source for Avengers, but they give me Avengers Infinity War instead. And so let me do this. Let me explain why I'm concerned here. So with our first source. So our first source is actually going to be, this is the one that kept coming up over and over whenever I was doing my Google searching, is this, the movie database. And so truth be told, I had never heard of the movie database before I started searching it for this project. It seems like a really nice site from both the perspective of, it's got this really clean little UI. And then, if we click on here, let's click out, I don't know, the Paw Patrol movie. Look at this. This is a nice UI. It's got a lot of nice information. Like, honestly, watch out IMDb. Like, TMDb is going to give you a run for your money. And equally so, they have a really nice API as well. So basically what I was saying here is, let's say I just do a search in here for Avengers. So before I hit enter, what the movie database is obviously going to try doing is giving me the most relevant results first. Just like in Google, if I were to search, the company Apple, or it's going to give me like information about the company Apple, and then probably next it'll give me like information about apples, like Macintosh apples or green apples or Granny Smith apples or whatever. So like, let's see what happens when I just search the Avengers here. Okay, so the Avengers Endgame, not the first result, and that's fine, and that would make sense. The Avengers is the first one now, and I just typed in Avengers, so it is just doing, or TMDb is just doing what it thinks is best. So it just returned Avengers because I only typed Avengers. Now, if I actually went back in here and typed in Avengers Endgame, then oh, it actually gives me two things. So it gives me the actual movie, which is the one I wanted, and it gives me this bonus feature documentary. And so the way, and I'll explain why this is important later on, but basically the part of the way I'm trying to counteract this is by, looking at the Google sheet here that I created for Kaylin's ratings. I tried to do my best to make sure that like the names of these movies are exactly spelled the way they need to be. And so obviously this is not the first time I've started to work on some of this thing here, but like I actually found that I did have a couple typos here and there on some of these movies. I'm trying to think of a movie that I had a typo on. Sicario, the sequel. I can't remember what the sequel was called. It's like something Day of Soledad or something. It's one of the last ones I put in here. I don't remember. But yeah, whatever it was, I had it spelled incorrectly, and therefore it wasn't returning search results correctly. So yeah, that is one thing, just the data integrity of trying to keep this fine. Yeah. So let's come back to here. So when it comes to our actually getting the data, we're looking at the UI here, but we want to be able to programmatically get at this via like something like an API. So fortunately for us, TMDB does offer its own API, and you can apply for what they call an API key. And the reason they give out API keys and they just don't open up their API, well, they don't explicitly state this, but I'm going to imagine this is why, is because they don't want people just spamming their API and just hitting it all the time with constantly searching for search results for performance concerns. Because if it's sad, there are a lot of bad actors out there who will just like create programs just to like basically mess with APIs like this. And so the API key helps to tamp that down by, kind of limiting like who can do what. And so that's why the good news is that they do allow, like the registration is free. The downside is that you do have to register with your email. That can turn some people on and off. So this is a perfect time to talk about one of the challenges that I ran into. It is not uncommon for APIs to do this. It is not uncommon at all for them to close down their API and then only allow entrance through an API key. TMDB makes it easy because I can just go in and let me find the link actually, and I put the link in here somewhere. Let me filling dead air with my voice. All right, so github.com/dkhuntley. I put it in the README. Well, no, I actually put it in the blog post here. Sorry about that. So I was starting to write. So the movies database. If I want to get... Okay, so follow these instructions here. Okay, so these instructions linked behind here. If I could get to the link, which I can't. Okay, anyway, I got this screenshot here. So whenever you actually apply for a TMDB API key, all you have to do is submit your email and a couple other basic pieces of information, and then you will see a screen that looks like this. And then obviously I purposely block this off behind this black square or dark gray square. That way you can't see that because I'm not going to share my API key. And so, please don't ask either. and you might be surprised. I've been asked for some pretty weird stuff before by random people on LinkedIn. In fact, I had to block one guy on LinkedIn who asked me for my Udemy login information so he could use my Udemy classes to learn the Terraform technology, actually. And, I nicely told him the first time no. And then, even taking that further step of, sending him links to free tutorials on how to do these things. And the particular course that he wanted to do was $12 at the time. And he, I don't know, he kept harassing me, like saying, I am tight for money. Please send me this. And like the tutorials that I gave him for free, because I know Terraform well, I know they were top-notch tutorials. And actually, HashiCorp, if you're watching this, you guys make some fantastic tutorials. But after a certain point, I just had to block the guy. It was sad. But yeah, so please don't ask me for my API key because I want to protect the integrity of both TMDB and like me being able to use this API key. But anyway, so the challenge that I'm going to talk about that I was starting to talk about though is that IMDb, the infamous source that you all are probably familiar with, also has their own API, but I'm trying to remember off the top of my head. I think they require that you actually have like a strong, legitimate business case to actually get access to their API. And you might be surprised, but my Kalen movie rating model doesn't qualify as a strong business case. So that's why I have to use these other sources, and that's totally fine because actually TMDB here, is our source number one, and it's source number one for a reason. This is a fantastic little API. And so, okay, so one thing I do want to point out before moving on, as far as, whenever so actually let me show you like my actual notebook here that I've already uploaded. So under this data gathering spreadsheet here, or not spreadsheet, Jupyter Notebook. All right, so you can see right here that, well, actually, let me scroll down. So whenever and we'll come back to this, but I want to jump down here for a reason. So whenever we actually instantiate this thing that we have to interact with TMDB, you can see that I am setting the API key right here from this TMDB key. And so if we scroll up, you might be wondering where we get that at. We are actually loading it in from this YAML file. So under this keys directory with keys.yaml, we are loading it in, and then we are extracting it out. And as you can see, we are never actually exposing my key out to the real world. And so there are different ways you can protect your keys like this. This is the one way that I opted to do it. Speaking of HashiCorp, I really wanted to get HashiCorp Vault working. I've been having some struggles getting that working on my personal machine. I got the dev version working, but for some reason I can't get the legit version to stay like what they call unsealed. So that's an aside, but anyway, so this is a simple way that you can hide your keys. And then in addition to this, so you'll see that I put the keys in the keys.yaml directory. So let's go look at that in the GitOps, or I'm sorry, my Git repo. So you can see, actually, let me come back to here. So coming into the movie ratings model, so you could see this is the same GitHub repo that I'm going to show over here. In fact, let me go ahead and, no, I'll keep this here. So you can see I got the container directory, data, docs, keys, notebooks, readme.md. All right, so let's go look at the keys directory here. Container, data, docs, what? No keys? No keys? Huh. So actually, I'm being a little bit dramatic here. The keys here are intentionally hidden by using this git ignore file. So if you're not familiar with what a git ignore file is, this is a great tool that does pretty much exactly what it sounds like. So let me go ahead and open up for you. So as it notes here, the git ignore file specifies things that Git should ignore. So you can have very specific files. You could have directories labeled like this. You can have wildcard star-like files that basically ignore anything based like on this pattern matching kind of thing. And so that's how I hid the keys directory. So actually we'll scroll all the way on down. Added by DK Hundley. Ignore my keys. So my keys are still on my local machine here. They are not on GitHub anywhere else at all. So that at least provides one layer of protection. Now, again, I don't really like using what I'm using here. I want to get Vault working just because if for some reason, excuse me, my computer were to crash and I didn't have things backed up, I would lose these keys for good because they're not on GitHub. And maybe that's fine. Actually, that's better than actually exposing them because I don't want to expose those keys out. But, so all right. So now that, let me show you an example of, coming back into here. I have, the keys. So I have the actual keys in this keys.yaml, which obviously I don't want to show you. And I'm so scared about clicking that I actually opened up this test.yaml on a different tab over here. Let's go ahead and look at that. Because I want to show you how you can actually make use of this. So under test, basically I nested this thing under test.keys here. So I've got my test keys, key 1, key 2, and then I created this like the dummy passwords of secrets and password. So if you actually wanted to load these up, the way you do that is by using the default Python library of YAML. So this is not something you have to pip install or anything. And then we actually open the file up and then use this YAML.safe load to save these things off to like this keys YAML like dictionary basically. So, and you can see, let me go ahead and restart and clear this whole kernel. Restart and clear all output. Okay. So All right, so now it's clean. Let's go ahead and run that. So you can see so far, the actual key. So this key here, this secrets and password, do exist behind this variable, but you can't see it. Now, if you were to print them out like we do here, then you would be able to see them appropriately. But unless you do that, then you're not going to see them. So, again, this is not a perfect pattern because, this if you do accidentally screw up by like printing them out or logging them out to somewhere, that can be like bad. But it's better than nothing. Like I at least I can still show you my code for my personal project here without the risk of exposing my keys. Okay, so that is, sorry for that little like sidebar there. I just want to make sure that if you want to follow along with my project, that you're not accidentally exposing yourself to something that you don't want to from a security perspective. Wait, need to take another sip. Oh my gosh. How are we doing? 40 minutes in. Okay, so we'll see how far we get. So I'm actually going to be pulling from 3 different sources to gather all the data that we need for our models here. And I don't know if I'm going to cover all 3 in this stream. But as a reminder, I am writing this blog post that will contain the full information of everything, as well as that whole GitHub, the GitHub project. I'm starting to lose my train of thought here. It's getting late in the day. So yeah, I'll have this published, and you'll be able to reference everything. But we'll see how far we can get here. Okay, so our first source, and in fact, I want to delete some of this stuff out of here because I don't want to be like cheating or anything. I'm not gonna. Well, I'll leave these other things in here. So let me go ahead and clear out all these cells just to show you that we're doing live coding. I didn't call this review my old coding. This is live coding, folks. Okay. So now that we have uploaded in our key, we are ready to begin interacting with the TMDB API. So actually, there are different ways you can interact with APIs. A lot of in this particular case, there is a person out here that wrote their own Python library that basically serves as a very nice little wrapper to interact with TMDB. With the API key and whatnot. So actually, let me go ahead and show that. Let me show TMDB v3 API, created by Mr. Anthony Bloomer here. This is a very nice little project. So you can see he's got a nice little README showing how to do all the installation and everything. And again, this will all be linked in the blog post and the GitHub README, my GitHub README. And he shows examples of how to interact with things. So here you can set your like API key, or like, so here's another alternative version of how to set the API key. I just opted for this pattern right here. And then he offers some different ways of interacting with things here. So actually, let's go ahead and jump back into our thing here. So I am actually going to load the legit key into my file here, and I'm not going to print out this one because I don't want you all seeing that. But what I am going to do is I'm going to go ahead and instantiate these objects down here that are going to help us interact with the movie database API. So you can see, first we're instantiating like this master thing, and this is basically the only reason we're instantiating this guy is because we need to like have it attached to our API key basically. And then we have 2 more objects here. So we have a search object and a movie object. So as you saw with like all of Kaylin's ratings or my spreadsheet there, we are going to be passing in the string name of the movie into this search. And I'll explain here in a little bit why we have a different one for movies. So let's go ahead and initiate our search with one of my favorite movies, The Matrix. So performing a search for or against TMDB for The Matrix. So sidebar, I don't know if you all are excited, but the Matrix Resurrections trailers look sweet. And I'm actually going to throw out, I didn't plan on doing this, but I'm going to throw out a random plug here. I follow this YouTube channel, and I got to look it up right now, called, I don't know why, I'm just really into the Matrix, called Matrix Explained. This channel has done a fantastic job at just like creating these awesome like theory videos of like what they think will be like Matrix 4 or just like some of the old Matrix movies. Anyway, I'm getting off topic. So back to our thing here. So anyway, so to do a search, we'll do a matrix. We'll call this matrix search results. Matrix search results. Now, again, this is one of those things where I don't remember the syntax for everything right off the top of my head. So we'll see if I remember this. If not, I do have it written down elsewhere. So matrix search results equals tmdb search dot movie, and I think it's a dictionary query, and then I think I don't remember. We'll see. I think it's query, and then you actually pass in the name of the string text name of the movie. So in our case, that's obviously going to be the Matrix. So it'll obviously tell me if I'm wrong here. Oh yeah, that's correct. I gotta do that. And search has no attribute movie. Okay, so I knew I screwed something up in here. So let me come back in here. Where did I do? Was I working on that? Okay, here we go. I'm just gonna copy and paste this here because this is the what I was basically trying to do. How far off was I, folks? Remember, when it comes to coding, memorization not as important as understanding the concepts behind what you want to do. It's important to understand, it's important to memorize concepts of like how a Python dictionary like is like the syntax works, but it's not important to remember things like the movie database search objects or whatever. So I was so close, one letter off. Movies. Wow. I can't believe I was that close. Okay, so now we have the matrix search results. So let's just go ahead and look at that very briefly, just as a whole. So matrix search results. Okay, so it's going to be kind of hard to tell, basically, like looking at this thing here. But basically, like, this is all the search results for everything in here. So this is actually a list of multiple movies, and it's really hard to tell this, but let's make it easier on ourselves. So let's do a little for loop to show you like that there are all these movies in here. So let's do for movie in matrix search results, print movie, and what is it called? Original title. Okay, so before I hit enter here, recall that whenever I did a search for, the Avengers, the first movie that came up was the 2012 Marvel Cinematic Universe Avengers, the OG that started it all, if you will. So let's see, whenever I do the search results here, what do you think is going to come up first? First, second, third, fourth. So actually, obviously, I already did this in a stream earlier today, so I actually know what's going to show up fourth. But I'm going to ask you folks. So first movie, you're probably going to guess is The Matrix, and I'm going to, spoiler alert, it is The Matrix. Second, third movie, which one? What do you guess? Those are probably gimmies. It's The Matrix Reloaded, which is obviously the second Matrix movie, and then Matrix Revolutions, which is the third movie. Now, what do you think is the fourth movie? I personally thought it would be The Animatrix. And I didn't know if the new movie that's coming out, The Matrix Resurrections, would be on here at all. So let me go ahead and show you, folks. All right, so here are basically our search results. So, like I said, Matrix, obviously number 1, Reloaded and Revolutions 2 and 3, but Resurrections hits at number 4. And notice in here, actually the Animatrix doesn't show up at all. So I don't know how this search functionality is necessarily working, but apparently it doesn't pattern match on parts of words, because Animatrix is one word, whereas you can see everything in here, has the words The Matrix as part of the title. And so you can see, obviously, these first couple are Matrix movies, but when you start getting down to like these last things, like I don't, or maybe they might, some of the, I'm looking at this one right next to my cursor. So actually, one thing to note is that you might have wondered whenever I was looking at these search results that like the very first attribute is called adult, because yes, apparently the movie database does contain information about adult movies. So I'm curious now because I don't really want to look more. No, I'm not going to look anymore. But anyway, so by the way, that is not a feature we will be using because Kaylin does not rate adult movies. So thank you, Kaylin. All right. So so this is like part one of the search with the movies database. So actually, let me go ahead and extract out just like the results for like just the matrix alone. So I'm gonna do this, except I'm just gonna put like index 0. So index 0, is going to be that very first matrix movie. So let me just do the search again, and so you can see now we just have details for the matrix. And let me go ahead and cut this out. It's because I'm zoomed in. I'll go ahead and cut that cell out. Okay, so it has a couple basic pieces of information about the movie, but not a whole lot. And I'm kind of surprised, at the information that's provided at this base search. So like you can see, we have like genre IDs, which doesn't mean much to us because these are numbers that don't really mean anything. We do have like the original language, which EN, common abbreviation for English. The original title, a brief overview, and a couple other things. The movie database does provide a lot more details than this. You just have to do an additional search. So that is why we instantiated this other object. And so the way, instead of passing it, so the nice thing about the search object is that we can pass in a string value, which is going to be which is obviously super valuable since all of our data about these movie titles is in string format. But the actual search for details of a movie requires the TMDB ID. So actually, you can see in here nicely. This is why we did this preliminary search result. Let me move my face out of the way. Sorry about that. The preliminary search result does contain the TMDB ID. So the TMDB ID for the matrix is 603. So actually, let me go ahead and save this. Matrix TMDB ID equals what is it? Matrix search results. And I'm going to call this ID. So just to print this out, matrix TMDB ID, and you can see a 603. All right. Now, I don't know if I'm going to remember how to do this search, but we'll try. Matrix TMDB details. So let's see if I can initiate this search on by memory using this object up here. All right, equals TMDB movies dot details. I think it's details. And I think you just pass in the numbers. So it's going to be matrix TMDB ID. Okay, it ran fine. Did it work? Matrix TMDB, not ID. We want the details. And details with an S. What do you mean it didn't? Did I spell something wrong? I'm confused, folks. Oh, duh, I spelled this. I can't tell you how often I've done that when writing this thing where I put BD instead of DB. My goodness. Okay, so it did work. I can't believe I actually remember that. So you can see lots of information. And a lot of this is like detailed stuff. So actually, let's just go ahead, kind of to keep it a little bit easier on ourselves. Let's just look at the keys of these things. So the keys. Okay, keys. All right. So you can see, I want to look at the matrix search result dot keys. Okay, keys. Okay, so if we look at the keys of the original search result versus the keys of the details, you can see there's a lot more. So there is some overlap. You got the adult binary Boolean. You have the backdrop path and still in here. But then you have new things. So we have things in here like budget, genres, and IMDb ID, which is going to be super helpful for us here moving forward. Revenue, runtime, lots of great things in here. And so I am not going to spend a lot of time explaining what I'm going to grab at it here because I've already done. I honestly already did do that, and I don't. We're already how far into this stream? Almost an hour into the stream, and we are only on data source number 1. Just for brevity's sake, I am just going to say, go check out this other notebook that I already started to create. So let me come back in here. So going into notebooks, the data gathering notebook. This notebook, along with the blog post I'm writing, is going to explain the details of everything that we're doing in here. So you can see we're only just testing out the matrix here. So I'm just getting, and I did things, we're just testing out the matrix here. But I actually created a little pipeline that will iterate through my whole or all of the movies that Kaylin has rated, and then basically get all the data that I want from those. So you can see that I'm getting things like the movie title rating, the budget, more revenue, things like that. And then so this script, this little script here is basically like a nice little pipeline that will curate all the data for us. And then at the end, this is what we see. So we actually get everything here that we need from TMDB. And again, I'm not going to go through a whole ton of details on that. If you have any questions, again, the chat is open. Feel free to ask them. I'm more than happy to answer, but I'm going to keep things brief. Although I do want to point out one thing. So you might recall that I mentioned earlier on that I want to make sure that I'm getting making sure that I'm getting the consistent movie from each of these things, or from each of these data sources. And so the really nice thing that TMDB has helped us out with is not only do they give their own TMDB ID, which this doesn't look right now that I think about it, because, well, maybe it is right. I don't know. I'll have to go back and look. But it also gives us the IMDb ID, which is great, because not only now, if we ever want to interact with IMDb, and more on that in a minute, then we can just pass in the IMDb ID without having, and knowing we have the specifically identified movie that we got from TMDB. So thank you, TMDB, for providing this ID. It's going to become very helpful. So speaking of IMDb, our second data source is actually IMDb. And so you might be thinking, well, Davey, didn't you just say that they locked their API? And the answer is yeah, but there is more than one way to get the data that you need. And so I actually did some Googling around, and I found this thing called IMDb Pi. And so IMDb Pi is not necessarily an API. It is a Python library that we can interact with very similarly with how we interacted with TMDB. I just honestly don't know how they're sourcing their data on the back end. I also didn't try to look too hard. I have two theories of how they're getting IMDb PY is getting its data. My first theory is that it actually does have access to the legit IMDb API and somehow is basically querying that on the back end of this Python library. And my other theory is that they're using some sort of fancy screen scraping in order to be able to get the data that we need. In either case, it works for us. I will say, though, that it doesn't provide as much information that I was hoping for. Okay, so let's go back to our Jupyter notebook here, where we're continuing to work with the matrix. So we do want, in order to be able to do the query against IMDb, we do have to do we need to extract this ID from here. So I'm going to call this matrix IMDb details, or I'm sorry, not details, ID equals matrix TMDB details what is it called? IMDb ID. Okay, and then I just want to just print this out, basically. IMDb ID. Boom. Okay, so you can see that is the IMDb ID that we need. So in order to make use of this API or this library here, we're gonna this is TBMD. I can close this out. We need to just do a simple pip install of IMDb PY, which I already did, and then we can instantiate these objects and then use them as such. So you can see I need to import the IMDb library into my notebook here. So I'm going to import this, and then I'm going to instantiate the object. So I'm going to call this IMDb equals, no, I can't do that. IMDb search equals, what is it? IMDb, is it just IMDb? I got to go back and look. No, well, with capital letters from IMDb. I guess I could have called it IMDb. Sorry, IMDb. All right, and so because this is not an API and kind of like a weird wrapper, there is no API key, fortunately, so we can kind of use this one out of the box. All right, so we have instantiated our object, so let's go ahead and do the search. So I'm going to call this matrix IMDb details. I just realized I skipped past an important topic. So before I forget, one thing that we noted in here whenever we actually looked at did I delete that cell? Whenever I was actually looking at the search results, matrix search results. Oh, that's because I extracted out just the one. Okay, whenever we did. Okay, let me go back in here. Sorry, I'm a little bit all over the place. I'm starting to get a little bit tired. Um, so the challenge with this is, I wrote this script. Here, where is my script? Oh my gosh, I got too much stuff open, folks. I can't find it right now. Where is my script? Where's my script? And I forget what I'm even looking for. Oh, okay. Yeah, I'm okay. So you might recall that just whenever I do the search results based off of the movie name, I'm basically just getting like the like the results of that movie, like the very first movie that it gives me. But what happens in a case where, for example, and this is a very specific example, Kaylin Rick reviewed the movie Pet Sematary, and so I'm not a horror fan at all, but I do know that Pet Sematary was recently re-released in theater, like as a new version, like 2 years ago. Whereas like there was an original classic from like the 70s or 80s, so I apologize if I get that wrong. But anyway, so the question is like whenever I search something like TMDB, which one's going to come up first? And so I actually, this is actually the first time I've ever looked at this. I don't know what's going to come up first. So actually, let's go ahead and do a search. Pet Sematary. I think I spelled this wrong. Pet Sematary. Pet Sematary. Terry. Not Ter 6. Ter E. Okay, so this is interesting. Wow, I was way off. It is 1989. So what you could see here when we did a search for Pet Sematary, it actually returns the classic first before the modern one. And so honestly, this is just a risk we're gonna have to take, because I tried putting like Pet Sematary 2019 at the end of like the actual string search, and it didn't work. Yeah, even in here, if you try to put Pet Sematary 2019, it didn't work. And so that's just a risk we're going to have to accept, unfortunately, like when it comes to these movies, that, whenever we do the search, it's not going to get the correct movie every single time. And, based off of like what your use case is, this is just a fun little project, so it doesn't matter so much. It may or may not matter, like if you make what decision you make for your company. Like I said, so for me here, it doesn't really matter if we have a couple mistakes here and there. I actually, when I look at the movie list here, like Kaylin's movie list, like I would actually wager to say that 90% of these are going to be right every time. It's just going to be like this other 10% that's going to fall in this weird gray area where it's probably going to return like something that's just not necessarily correct. So yeah, and so just be mindful of that whenever, if you were to like actually build your own model around this. So I do, like I said, Kaylin actually rated this version of Pet Sematary and not this one. So that is going to be incorrect as part of the model, and it's just when it the reason I'm not overly concerned about that is because like when you start gathering a ton of data, like let's say Kaylin were to have rated 1,000 things, I would actually say probably at most 40 of them are gonna be in this weird gray space. So you're at least 96% correct, and that's still pretty dang good, or a lot better. It's a lot better than 0 or 50%. I'll tell you that. Okay, so I apologize for that little tangent, but I thought it was important to bring up. That's just a risk we're gonna have to accept, and I even noted that here in the blog post somewhere. Yeah, I even used the exact same example, Pet Sematary. And actually, when I typed this, I didn't know which one it was going to give me, and now I do know it's going to return the older classic. Okay, ooh, lots of talking. Let's get through IMDb. So actually, as this post is being written, I actually haven't done the third data source yet, and I was thinking about doing this live. But we're going to get through IMDb, and then we're going to call it a night, partially because I'm getting tired, and partially because my voice is actually starting to give out from talking so much. Keep in mind, I've been streaming for an hour here, or an hour and 10 minutes actually, but I also streamed for 45 minutes earlier to basically dead air. Okay. Taking a sip. Again, chat is open. I don't see any questions so far, but again, if there are any questions that arise, please feel free to ask. Okay, so let's go back into our Jupyter notebook with IMDb. So what we had done was we extracted out, as you recall, the matrix IMDb ID that we're going to be using as a search in here, and this is where I'm going to have to go back and look and I'm actually going to try to see if I can just do it off of the README here. So, okay, it's just get movie. All right, so let's come back in here. Get movie, IMDb search .get movie, get movie, and I know that there is one gotcha, and you'll see what it is here in a second. IMDb or matrix, IMDb ID. Okay, so the gotcha is that it is looking for an integer, whereas we're providing it with this string value. And so actually, I originally thought, well, why did they put this TT in front of it? Because actually the TT is in front of all these IMDb IDs. And I thought they had screwed that up. But then when I started researching it later, that is actually correct. But for some reason, this API or wrapper can't handle that. This is kind of odd. It actually does work if you just take off the TT. And so the way we can do that is just like doing this, which is basically saying, okay, instead of take this ID and instead of starting at the 0 value, start at 0 index value, start at index value of 2, which is the 0 here, and just basically doing this. So just to show you like that this actually does work. So you can see that it's only going to give us that. And then we can do that. And then we can do a matrix, IMDb details. And then you can see, because I had to wrap this in a dictionary. So by default, it doesn't give me a dictionary object, which is fine. But I can wrap that as a dictionary, and then it should output in display just fine. And for some reason, this actually like takes a little bit long. Well, actually, no, this does make sense. So IMDb, or at least this version of IMDb PY, gives us a ton of information, but it's a ton of information that is not going to be useful for our model. And so what I mean by that is you can see that this whole section here, well, actually, let me just do a keys, because sometimes it's easier to look at keys. So you can see all this information, but a lot of the information is just about people that supported the movie. So like the cast, you can see here, the sound department, the visual effects, the stunts, even the camera department. And so I think it's cool that they do recognize these individuals, but unfortunately that's just not going to be provide us a whole lot of valuable information from our model. In fact, so I mentioned above that I wasn't going to go into the details of like what I got all from TMDB, but I will say that IMDb here, the only things I think I can use were rating, which actually there was a rating above here in TMDB, but I did some research and found they were different. I don't know how they are different or why they're different, but they are. And then same with votes here. So that's I already got genres from TMDB, so I'm not going to worry about that. I already got run times from TMDB, so I'm not going to worry about that. I actually didn't get year the first time around, so I'm curious. I'm going to look at that. Matrix, IMDb, details. Yeah, year. Okay. Not dot. Oh my goodness. Okay, year. Okay, 1999. Okay, so I actually didn't include this originally as part of this other notebook, but I think I'm going to add this. And then whenever we actually do feature engineering, we can't keep the years like this at like the actual numeric value. But what we can do is change this to a relative value. And what I mean by that is, we can't use the date like 1999 because it doesn't have any that dates themselves by in and of themselves don't like hold like value for a machine learning model, but we can do something more relative where we can say, okay, how many years has it been from 2021 to 1999, or basically how many years old is the movie? And so that is something we can feature engineer, and that is something that would be useful. And I don't know why I didn't get this the first time, but or maybe I did as part of TMDB and I just don't remember, because it's been a couple weeks since I've done this. So TMDB, I can look at my values here. I actually didn't. Wow. So cool. That is something I do want to add. I will definitely make sure to add that. So, in fact, I'm going to go ahead and add this live here. Okay. If rating is not in TMDB detail. Yeah, so some of the things that I'm not covering here is that I had to do some fancy footwork around dealing with basically null values. So same thing above here with TMDB. One thing that I did is extracted out genres. So there was a primary genre and secondary genre, but most movies did have at least one primary genre. There are a handful that didn't have a secondary genre, and then there was at least one that didn't have genre listed at all. So this is what this code is doing, is handling like what happens if there's null values. So it's basically looking at the genres here, so you can see the length of the genres. So let me actually show this in the other notebook here. Matrix, TMDB, details. I think this is still correct. Okay, yes, and then I want genres. Okay, so you can see here that we have, and you might even recall earlier when we were doing the preliminary search results that I only returned the genres with the ID, which isn't very descriptive for us, but it actually gives the name here. And so what we can do here is we can say genres 0. So that's going to give us just that. And then if we wanted to get even further down, we can just do name, and then we get just like the action here. So yeah, you could see there that it did have a primary and secondary genre. But if it didn't, then that's what this code over here is handling. So like basically, oh, sorry, that's what I wanted to show is, so here you can see we have 2 entries. So if I just did a len, which is abbreviation for length, so you can see there's 2 entries. And so that's what this code is doing, is it's examining the length and then executing some like script based off of that, based off of the conditional values of whatever exists there. And so I had to do some fancy footwork for genre there. I found some other like issues before with TMDB, like not having rating or anything. So let me see if I can't. Well, no, I have to run all the cells again. And so actually, honestly, whenever I actually run these, what I call my data pipelines here to actually build these things, it takes a little while. Like not a ton of time. It would take just like a solid 5 minutes. But I don't think you'll want to sit here and wait for 5 minutes while these things run. But I will add year in here. But that's really it from the IMDb data. So you can see that I start to do like concatenate everything together. So this is our raw data frame. You might recall that we can't use this data for much as it is. We have to do some feature engineering in the which will be our next stream. But yeah, so basically, we got our first 2 data sources, and like I said, I hadn't really started on the 3rd data source yet, but the reason I do want the 3rd data source is because I think I mentioned toward the top of this stream that I really wanted the Rotten Tomatoes scores, and so far in the first 2, I mean, as great as TMDB was and great as IMDb is, they didn't have the Rotten Tomatoes scores. And so I did some Googling, just about an hour ago, or not an hour ago, a little over an hour ago on right before the stream started. And it looks like this 3rd source, the Open Movie Database, is going to be provide those Rotten Tomatoes scores like I'm hoping for. And so I'm not going to do this one live because honestly I'm getting tired and my throat's wearing out. And so in fact, this blog post that I started to write here probably won't get done tonight because I need a break. But anyway, in my preliminary search, the Open Movie Database works very much like OMD or TMDB did, in the sense that you have to get your own API key. I already went ahead and registered and got it myself, and it's actually already good to go. But yeah, obviously I've not written the code for this quite yet, but I'll get there. If I don't do it tonight, which I probably won't, I'll probably do it tomorrow. I don't have a lot going on this weekend. Speaking of that, let's call it a night there, because I am pooped. That was a lot of talking, and my throat is just very scratchy right now. Yeah, I hope you all had a lot of fun learning about this. If there's anybody on the water cooler watching, hope you all guys enjoyed this. Hope it wasn't too boring for you all. So I think when people think about predictive machine learning models, that's this really fun, fancy, or really fancy pants kind of thing or they like to think of Skynet, or I always forget HAL from what movie. I always remember HAL. Well, so fun fact, if you didn't know this, so HAL, the way it got its name, HAL is an acronym. I don't remember what HAL stands for, but it's HAL. So move the letters of the acronym over one space in the alphabet. So H to I, A to B, and L to M. So HAL, and then there's IBM. Ooh, fun fact. So y'all learned something there. Yeah, so it's actually, that's why HAL has its names. And then even more further on, if you like the Kirby games are made by HAL Laboratories. So there you go. Speaking of that, last week, the Kirby preview totally not expected, but that game looks cool, and I can't wait for it. So speaking of games, I actually bought a Switch capture card, so I actually can now do live streaming like this on Twitch with my Switch. Twitch Switch. Wow, I've never heard of anybody say that. All right, I am getting super like God mouth, so I need to call it quits. I hope you all enjoyed this though. I will be sure to get all this code pushed out. You know, if not tonight, then tomorrow. I will finish the blog post. I will publish that out, and then we will get on to feature engineering probably in our next stream. And like I said, we will get back to the Titanic data set. I've just got so many ideas going around for these streams that it's hard to know what to do next. And I just thought this one would be a fun one, but. So yeah, let's go ahead and wrap it up. Hope you all have a great weekend. And for my water cooler guys,
woof woof.